Hello, my name is Hank Lee. Today I'm going to talk about the application of fracture mechanics. Before talking about this topic, let me first introduce fracture mechanics. When I heard about this the first time, I was so confused. What is fracture mechanics? Why should I learn that? After learning that during classes and searching on the internet, I started to understand this. This is a new branch of mechanics which studies the law of crack propagation in materials and engineering structures. Fracture mechanics refer to the microscopic and macroscopic cracks visible to the naked eyes. Various defects in engineering materials can be seen as cracks. It can be divided into linear elastic fracture mechanics and elastic plastic fracture mechanics. The former is suitable for small yields near the crack tip. The latter is suitable for a wide range of yield near the crack tip. In online elastic fracture mechanics, the most important mechanical parameter is stress intensity factor, which controls the stress and displacement fields near the crack tip field. So what are some applications of fracture mechanics? Ultra-high strength steel is widely used in aviation, aerospace, and other military industries, and has also been extended to construction, automobiles, bridges, and other fields. FM testing is crucial to assessing the viability of a particular material for use in each component. This growth is being driven by the demand from regional equipment manufacturers to offer lighter, stronger, more durable, and damage-resistant airframes. This means that innovative solutions have been developed through the improvement of metal alloys and by breaking new ground in the creation of new non-metallic composites. But as these materials become more demanding and as new materials are created, it becomes more necessary to assess the characterize their property to predict their failure. Fiber reinforced polymer-based composites are increasingly used in high-performance aerospace structures and components due to their lightweight and associated high specific strength and stiffness. The development of fracture mechanics testing methods for these materials has resulted in several standards over the past 30 to 40 years, and additional standard procedures are being prepared. The current status of standardization is briefly reviewed, and the applicability of fracture mechanics data to composite design and other application in aerospace is discussed. The main issues are laminate laying, fatigue, behavior, and service conditions. These are illustrated by selected data from fracture mechanics literature. In hydraulic engineering, single or several buildings with different functions and types are often used to regulate water flow to meet the needs of different departments for water resources. This for the water conservancy in addition to water damage and construction of building called hydraulic buildings. The cracks in the large volume concrete of hydraulic building will have harmful effects on the building due to the physical and mechanical effect of the permeable water flow in the cracks. Therefore, many hydraulic buildings have crack prevention requirements. However, it is not easy to use the ordinary design theory to ensure that the crack is not cracked, and it is more difficult to judge the stability of the crack once the micro crack is formed. So the more conservative criteria and methods are often used. The development of fracture mechanics has achieved good results in research and solution of the related problems of metal material cracks. So it has been widely used in the design of metal structures, but its application in hydraulic structures is still rare. In this paper, Several applications of fracture mechanics in hydraulic design are discussed, such as the stability of penetration joints in concrete, the function and calculation method of joint cracking, but the determination of crack depth and the cracking problem of the upper surface of concrete damage are given. These suggestions are derived from diagnosis, and their applicability remains to be tested in practice. In short, fracture mechanics may be a useful tool in hydraulic design, but needs a lot of research and test work to be widely used in practice. So those are the applications that I know right now. And I believe that we have more in our real life because it is really important. Thanks for listening.